Hi guys, welcome to Learn Electronics Repair. This video is sponsored by PCBWay. PCBWay are a premium PCB manufacturer. They will make prototype PCBs, small and large runs of PCBs, and also populated PCBs that can build your project for you. They also have a shared project section where you can upload your own projects, and if people want to buy your PCBs, you get a commission from all the sales. This is PCBWay's website. You see they have some offers at the moment. You can get 10 PCs of PCB made, $5. They also have an assembly service. You can actually get them to populate the boards for you or partially populate the boards for you. This is the shared project section that I mentioned, so you will find on here thousands of projects that people have actually designed and uploaded. They have a search facility. You can look to see what is there. You can see in each of these sections there are many projects, and we can look at a few more categories as well. So these are all the various categories. For instance, making your own keyboards, mechanical keyboards. So we can either, as I've done, start building a project, or we can actually have a look at the existing projects. Okay, and here we are, mechanical keyboards, for example. So this is a very good place to come to find interesting things to build. Now let's have a look at our own project. We're going to look at one that we previously made a prototype for PCBWay. We will design it. It's the first time I've ever done a PCB design, so let's find out how easy or difficult that is. I mean, hey, how hard can this be? And then hopefully we will upload the design and I will show you how to order PCBs from PCBWay. So in this video, we're going to complete the PCBWay signal injector. I'll link the previous video where we built a prototype for this on Vero board, but using surface mount components, and it actually fits inside the pen. Today, I thought we'd have a look at PCB design and layout. This is something completely new to me. I've never done this before. I have watched a 10 or 15 minute tutorial video showing how to do this, and I'm going to use some free software called Easy EDA. This is not really a full tutorial on Easy EDA. This is an absolute beginner showing you how I go about doing so. I've spent an hour or so just playing around with it, doing the things I could see on the instructional video I watched, and I think this is going to work. So let's draw the schematic for this. Let's then create a PCB, and then we will order those PCBs from PCBWay. We can have a look to see how much they cost, how much the shipping costs, how long it takes, and then once the PCBs arrive, I can build some and we can have a look to see how well they work. Okay, so let's begin from the beginning. So I've just searched in Google Easy EDA and found easyeda.com, and we can go to the website. We have here pricing, but I will explain to you this is a free piece of software. So we have the standard edition, which is free forever, and we have also a professional edition, which says it's free now. So you can use this, and I'm actually using the standard edition. This is free software. Having said that, it has all the features you would expect, I believe. So I've actually downloaded the software and I have installed it on my computer, and I will show you that now. I've installed Easy EDA on the computer. It was just a standard Windows install. So let's run that. And we're on the home page of Easy EDA. We'll create a new project. You can see I've been playing around a little bit with projects, but we'll create a new one. So we'll call this the LER, Learn Electronics Repair, PCBWay injector pen. And we'll spell it right. Okay, so that's how we do it. You can put some sort of description in here. My first PCB, that will do, and we will save. And now we have a blank sheet. We can put some details in here if we like. Your company, learn electronics repair. Yeah. We can call it injector pen. Just click on the thing. Injector pen. Okay. And any other information we want to put in here. And now we need to draw the PCB. And this is quite simple actually. This is a beginner's guide if you like, but this is how I figured out how to work it. I went to Common Library, and then here I can pick up the various symbols I want. So we need a ground, okay, and you try to drag it like this, it says you can't. I'll show you the mistakes I made. So ground, ground. We can have more than one ground. The software will consider everything that's marked as VCC to be power, ground to be ground. Our schematic actually had 4 resistors, so we can put some resistors, and look, it's just automatically calling them R1, R2, R3, R4. We can press escape to stop adding resistors, and now I can type in the value. So we want 2 22k resistors. Okay. $22k. We want a 150k resistor, 150k, and we want a 240k. No, I tell you, it wasn't 240, it was 220k. So there are our resistors. We also need 2 capacitors. We can use whichever symbol we fancy, but this is showing the size. So the resistors I'm using are surface mount. This is a surface mount project. You can see the size 0603, and the capacitors I want, I'm going to use again 0603. I've done it again because I don't learn fast. Okay, we want 3 capacitors, and they're all the same value, which is 100 nanofarads, which in actual fact is the default value. 0.1 microfarads, the same as 100 nanofarads. So we have 3 capacitors. We also now want 2 transistors, and I will pick the ones in the package I want. You can see I'm hovering over. Hopefully that's coming up on the video capture. SO223. So I remember to do it right this time and not try to drag them onto the sheet. I have 2 transistors. I need a couple more things. I need a push switch. We'll go with this one. And we need a battery. And I think there was actually a battery here, yeah. CR1220, that will do. We'll put that one in there. And that's all the parts we need, really. Now this is a very simple circuit, but it will show a few of the basic features of this. If you're learning to use something, do something simple first, yeah. So I can select the resistor. I dragged around it this time. If I hit the space bar, it will rotate it. I want all my resistors to be vertical. I can select all of them, rotate them. The capacitors, I want them to be horizontal. This transistor I want to turn around. So can I drag around it? Yeah. Okay. It's turned around, but it's now upside down. I want to effectively flip that one vertically. So we go to Format and flip vertically, which is actually Y on the keyboard. Yeah. Switches them up and down. So we have those all the way we want them, really. Now let's start to draw our circuit. So R1, we can just drag it here. We can put them in order. R2, okay. R3, R4. There's probably some option that evens up the spacing. I haven't found it yet. but we can put them there. These will all connect to VCC, which is power. Notice I've dragged the label there. I've done this before. Now I actually want the whole thing. Grab it by the bar and not by the label. That seems to solve that one. The capacitors, yeah, one of them is going to go here in between the two resistors. The other capacitor, same position between these two resistors. And this capacitor, grabbing the symbol seems to work, is going to be the output. Okay, we have our two transistors. One will connect to these resistors and capacitor. The other one will connect to the other one. So you see, I'm just dragging things around into a rough position of where I think I want them. We can level things up too, I've noticed. So for example, if I select this one and hold, I think it's control, and select this one, I'm pretty sure we can tell it to align the tops. Yeah, so if they're not even, you can do that with them. Now we need our battery, which is here. Just zoom out a little bit. There's the battery, and the battery is going to connect to the switch, and the output of the switch switches the ground. Okay, that's how I designed it. So the other VCC we can actually put here somewhere. The other ground, zoom out, let's have some grounds. We can put one of them over here and one of them over here. So this software basically knows all the points called ground are connected together, all the ones called VCC are connected together, and if you wanted some other ones, if you change the names, the labels to match, it knows they connect together. That's roughly our schematic, but now obviously we need to draw some wires. We need to connect the components up together. So let's do that next. To do this, we need the wiring tool, so we click on it. And first of all these resistors, we want them to connect to VCC. So I just go to each one and click. Click again to start. Click to stop. Click again to start. Click to stop. Click again to start. And we want these to go to VCC. Okay. So there we have those points all connected together. Let's draw some more wires. So we want to go from this resistor to the collector of the transistor, and we also want to go from the capacitor to the same place. This resistor goes to the capacitor. Okay, I can zoom in. This resistor goes to the capacitor. This resistor goes to the transistor, and from here it goes to the capacitor. Okay. The output capacitor goes to the collector. So you can see how easy this is. The two emitters connect together, and this is ground. I'll move the ground symbol a little bit closer. So if I press escape, I'm now back into the move option, so we can put ground here. We can zoom in again. We can go back to the wiring tool, and we can connect from here to ground. So we have those connections. The only two we need now are from the base of each transistor to the opposite capacitor. So we can go from here. You can't go diagonally, but we can go effectively. Click again. We can go up here, click again, and we can go to there. So that's one of them. And this one I'll draw. There's no doubt a tidier way of doing this than the way I'm doing it. I'm clicking each time I come to a right angled turn, basically. And we have. Let's put our battery. So this is the positive end of the battery, goes to VCC. The negative end of the battery goes to the push switch, and the push switch connects the negative end of the battery to ground. So that's our battery connected. We could draw lines from here all the way across to there, but that's quite tidy, I think. So we will go to design, convert schematic to PCB. Okay, and it's saying check nets. That's now checking that every point has got somewhere else to connect to. Okay, and it's checked the nets. And on the left hand side we can actually click on them. So we have ground, and you can see that it's come up like in a bold, and you can see that ground connects to this ground. We have key 1, yeah, so that's that one. We have R11, so it's showing us that, and so on. R21, yeah, to the base. R31, R41, and VCC. So we can see we have all the nets there. The only thing we don't have is something connected to the other end of this capacitor. This will go to a pad where we will solder the probe on. So let's see if we can add that. I'll go back into components, a connector. We'll have a connector, so we'll stick a connector here. You can give it a name, J1, and we can connect our capacitor to the connector. That will put a pad on the PCB that we can solder the probe. Escape. So there we have it, really. That's our design. Now we need to make a PCB. To make the PCB, we need to go to design, convert schematic to PCB, as we did before. It's saying please save your file before you convert it. Okay, file, save. It makes sense, we need to save the file. Now let's try it. Convert to PCB. Processing, and it now shows us the PCB. The first thing we need to do is put the size in. Now our PCB needs to fit into the pen, so I'm going to make the width of it 45 millimeters, that's 4.5 centimeters, and the height I need it to be 10, otherwise it won't fit in the pen. We want units in millimeters. The board is going to be a double-sided board, and we can choose the shape. So circular, rectangular. Round rectangular just puts basically curved corners on it, but I'm just going to go with rectangular, and we will apply. So there is our PCB. Now we need to place the components. The battery I will put near the end. You'll notice it's actually larger than the board. I'm actually going to use a smaller battery, but I will have the pads on the PCB where I can attach my own little battery holder, whatever I use. So that we can put there. The key, this is the on-off switch. We can stick it here. And the components we can drag to the board. I'm going to lay this out very much like the prototype I made. So R1 can go here, and I need to rotate it, which is the space bar. Okay, zoom in a little bit. R2 is going to go up here with it. Okay, and the capacitor which goes in between is going to go there. You see the lines like elastic dragging over here. We can do the same with the other resistors. So R3, rotate it. R4, we can rotate it. So I'm getting a rough layout. C2 is going to go up here somewhere. Then we have our two transistors. So Q1 is going to go underneath this one. And I want to rotate that round so the collector is at the top. Okay. Q2 is going to go here. Rotate it again. And then we need to put the capacitor in and the connector to the probe. Now you'll see it's a little bit small. The capacitor, kind of like the wire, comes in where this line is and goes out there. So let's just select the capacitor, rotate it a couple of times. It's just easier for the layout. it's now rotated the label. Can we actually rotate that separately? I've not really tried this before. I'm sure we probably can. Yeah, you can see I'm moving the label around. I can also drag the label. Okay, that looks good. This can go up here somewhere, and now we need to fit it on our board. I'll just zoom out. Try to zoom in. Oh, there's a scroll bar, of course. Yeah, I'm off the screen. That's the scroll bar for that. Okay, we do it that way. Let's have a look now. So we can see that all the tops of the resistors are connected together. So that's a kind of a sensible layout we have. These two are going to the capacitors. These are going to the capacitor, the transistor. Capacitor, transistor. We can see the two that cross over. So we need to put the output capacitor in. And we need to put the probe. I'm going to move the switch a little bit further over. I want it in the center. I can now move these a little bit further over, and I should get a bit of space. Okay. The resistors I want level. Let me do that first. I've got them, yeah, they're all in white. Now let's try to align them. No, Control Z. I notice when you do that, it kind of like deselects all of them. You have to do it again. Okay, they're all selected again. Align the tops. Yeah, now they're all in a line, okay? The capacitor now can go across here a little bit. And this capacitor can go across here a little bit. And our transistors can now be moved a little bit more onto the board. Okay, I'll line up the two capacitors because I think they're not quite lined up. Let me see if I can select them. Looks like you have to select effectively the name as well. Yeah, that's got them both. Look, the labels are also on. We can align those. Yep, they're lined up with each other. What else do we want to do? We want to move these labels around a little bit. Q1. We can have them vertical. I'm fine with that. Q2. Again, I can line up the labels. R3. R4. C2. C1, R2, R4, R1. Okay. I'm holding Control in. I've selected all the labels. Can I line them up? I'm thinking I should be able to. Oh, it's align the top. Let me try to align the bottom. Yeah, that looks good. The same with my two transistors. Just hold the control button, select the label, align the bottoms. Yeah, they're okay. No, I want to align the top. That's looking good. The capacitor ones look good anyway. The one for the switch, that looks good. This symbol here we can move over here onto the board, and now we just have the capacitor, which is the output capacitor, and the test point. Okay, we need to find a little bit more space on our board. I think we'll move the other transistor over to here. Okay, the capacitor can now go in here, and the test point will fit near the middle. Okay, that looks a little bit messy, but it's the first attempt. Yeah, first attempt. The only thing wrong with it really probably is that I just need to move the labels slightly. Okay. I've moved plenty of stuff around now. I think I'm fairly happy with that. I have to move this one. Yeah, label. Let me get the label. J1. Test point can go there. And the label can come here. Okay. So we now have our components where we want them. Let's now ask it to route the PCB. First of all, I will save. We've saved our work so far. Then I will go into route and auto route. There's an option here for design rules. This is for your PCB manufacturer. I could go to PCBWay and input the minimum track width they can make, the minimum clearance, the minimum via diameter, the minimum drill. But I'm just going to leave them as they are because PCBWay will audit my PCBs before I pay for them, and they will tell me if there are any problems. So let's just make this PCB. I'll select auto route and I will let it do it for me. So run. Okay. Nothing failed. There are 4 vias. These are holes in the board. And it's made it. So we can see it's put a couple little vias here. It's put one down here, one down here. And there is our PCB. I can move things around and adjust it, but you know guys, I'm quite happy with that. To order our PCBs from PCBWay.com, we need a Gerber file. So we can go to File, Generate PCB Fabrication File, Gerber. Okay, it's asking us again to save the file. So File, Save. Now we'll try to get the Gerber. So Gerber. This is saying you can check for the rules, design rules. I'll tell it to do it. And we have our PCB. And it looks very nice. Yeah, we have our PCB. So I'm going to tell it to generate the Gerber file. It will now ask me where I want to put it. And it will also give us a name. We could change it, but it's this one. LER PCBWay injector pen. Save. I could also, by the way, put some silk screening on here. I can put the name of my channel or anything else I want. But these first ones are going to be prototypes. And then if I want to upload a finalized version, I can do. So we have our Gerber file and we've finished with Easy EDA. So we can shut this down. We're done. Yeah. From here, I can order the PCBs. So to do so, we go into PCBWay Instant Quote. And this, guys, is so easy. It's as easy as what I just did with Easy EDA. And it definitely is easy, even though I've never used this before. So PCB Instant Quote. From here, I have the option of the various types. I want standard PCBs. I'm just going to leave everything as it is, and I'm going to go to quick order PCB. In fact, actually, I could now leave everything as it is, but I'm actually going to change the color to red for the solder mask because red is the color of the channel. So we'll change that to red, and other than that, I will leave everything exactly as it is, and we can go to quick order PCB. Now I add the Gerber file. So add Gerber file. And you can see it's that one. Yeah, it's a zip file. That's fine. Open it. It's reading it in. It gives me the size of the PCB. There is our PCB. You can see the 2 little tracks on the back. And you can now see the price. So the production time is 24 hours. I get 5 PCBs. And the price is $5. Before I order these, I do need to sign in, but I will show you, yeah? So, $5, 24 hours. On the shipping, I have actually selected the global standard shipping I'm going to choose. So the shipping is $3.94. It's saying 9 to 13 business days, and it's actually, if you look, a little bit cheaper than the AliExpress standard shipping. But we can use various options. We can have express shipping, 3 to 5 business days, whatever we want. I'm just going to use the cheapest option, and I'm happy to wait 9 to 13 business days plus the 24-hour manufacture. So we'll apply that to our order, and you can see the order is now $8.94, and I will save that to the cart. It will almost certainly now tell me I need to log in. And here you see the orders I've already placed. This is the one I've just done. Solder mask red. Yeah, you can see it there. So this is a previous order I made for something else. So that is now in my cart. I can proceed to checkout, and I can check out with the order. Because I have a sponsorship deal with PCBWay, I will just let them know that I've placed these 2 orders, and then they can build the PCBs for me. So I hope you see just how simple that actually is, even for someone like myself who've never done this before. You can see that it was very simple. Okay, the PCB was a simple PCB, but that's where you start, yeah, with an easy one. I hope you enjoyed that quick look around Easy EDA and PCBWay's website. You can see how easy it was really for somebody who is a complete beginner to make that PCB, to place the order with PCBWay. You can see the total cost was about $8.50 for 5 PCBs, so that is less than $2 per PCB. That's very cost effective if you're not in a desperate rush to get the PCBs here quick. As soon as they arrive, we can have a look at them and we can build this project, and then we can make any changes we need to do and finalize the design. One other thing I noticed while I was having a look at Easy EDA is that there appears to be a large community and a lot of shared projects on there, which means you can look at other people's projects, you can download them. When you create a project in Easy EDA, you have the option to upload that effectively to the cloud to share it with everybody. So I'm going to have a look around, see if I can find any interesting test equipment related projects to build, and then we can do that. We can look at some other people's PCBs and order some more from PCBWay, and we'll have a lot more interesting things to build in upcoming videos. I hope you enjoyed that, guys. I hope you think that was easy, and I do hope you found that helpful, especially if you've never done this before. Hopefully now you will feel encouraged to give it a go. Okay, so I will see you all soon on another Learning Electronics Repair video. Ciao for now, guys.